Welcome student, in this video we will see the design of sequential circuit with the solved problem. First we will see the procedure for design of sequential circuit. The first one is obtain the design specification and study the same clearly to understand the operational behavior of the circuit. Second one, construct the state diagram. Third one, develop the state table. Then fourth one is reduced standard form state table by removing the redundant states. Fifth one is state assignment and transition table. Assign the binary values to the states and write the transition table. Choose the type of flip-flop and form the minimal expressions. Then seventh one is draw the K-map and find the minimal expression. Draw the circuit to realize the minimal expression and obtain the above, that is obtain the design of sequential circuit. So, this is a procedure for design of sequential circuit. Now, we will see the problem, solved problem, so that we are able to understand clearly. Now, we will go to the problem. So, the design of sequential circuit, solved problem 1. Design the sequential circuit with D flip-flop. State diagram is given below. So, for designing the sequential circuit, the state diagram is given in the problem itself. Right? State diagram will be available in the problem, available in the question. Here we need to design with the D flip-flop. The sequential circuit has one input and one output. Right? So, it has one input and one output. Now, we will see the state diagram. So, this is the state diagram given in the problem itself, question paper itself, the state diagram will be given. From that we need to frame the state table, right. So, in this state diagram there are 4 states available 0, 0, 1, 0, 1, 1, 0, 1. So, these are all the 4 states, right. So, this is nothing but these lines are nothing but how it is going from one state to another state, right. So, this green color line, the state goes to the same state, the 0 0 goes to the same 0 0, that indicate by the green color line. This red color line indicate from one state to another state. These two binary numbers is nothing but first one is input slash by output, the first one input, the second one is the output, right. So, there are 4 states available 0 0, 1 0, 1 1, 0 1. The states from one state to, it will go from one state to another state or in the same state itself. These two binary number, first one is input, second one is output. Now, from this we can frame the state table. So, this is the present state, this is the next state for 2 cases, for x equal to 0 or x equal to 1. This is the output, for that also 2 case, x equal to 0 or x equal to 1. Now, we will see this. First, we will take the state 0 0. See, this 0 0 goes to 0 0 itself. For input x equal to 0, output also 0, right. 0 is a present state 0 0, next state also 0 0. 0 0 goes to 0 0 itself. For input x equal to 0, output also 0, right. This 0 0 indicated here. This is 0, this also 0. Input is 0, output also 0. Then this 0 0 this goes to 1 1, right. 0 0 goes to 1 1. For input and as well as output is 1 by 1, right. 0 0 goes to 1 1. For input x equal to 1, output also 1, right. 0 0 to 1 1, this 0 0 to 1 1. The input x equal to 1, output also 1, right. So, this condition is over. Now, we will go to this 0 1. Right, 0 1 goes to 1 0 for input 0 as well as output 0. 0 1 goes to 1 0 for input equal to 0, output also 0, right. This 0 1 goes to 0 0 for input 1, output is 0. 0 0 goes to 0 1 goes to 0 0. 0 1 goes to 0 0 for input x equal to 1, output is 0, right. Input 1, output is 0. So, this condition is over. Now, we will go to 1 0, right. This 1 0 goes to 0 0 for input 0, output 1. 1 1 0 to 0 0, 1 0 to 0 0, input is 0, output is 1. The same 1 0 goes to 1 1 for input 1 output 0, right. So, this 1 0 goes to 1 1 for input equal to 1 output is 0, right. So, it is clearly from the diagram we can write this state table. So, this is also over. Now, it is 1 1. So, 1 1 goes to 1 1 itself. For input equal to 0 output is 1, right. So, 1 1 goes to 1 1 itself, input equal to 0 output is 1, right, input 0 output 1. The same 1 1 goes to 0 1, 1 1 goes to 0 1, for input equal to 1 output equal to 0, 1 1 goes to 0 1, for input equal to 1 output is 0, right. Now, from the state diagram we framed the state table, right. So, what is the present state, what is the next state, what is the input, what is the output, all are available in the state table. From this we need to design the D flip flop, excitation table for D flip flop, right. Before that we will see how many states and how many flip flops are required. The number of state is 4. So, the number of flip flop is calculated from this condition 2 to the power n minus 1 less than or equal to n less than or equal to 2 to the power n. This capital N is nothing but number of states, small n is the number of flip flop, right. First we will substitute n equal to 2. So, 2 to the power 2 minus 1 less than or equal to 4, this is the number of states, less than or equal to 2 to the power 2, that is 2 to the power 1 less than or equal to 4 less than or equal to 4, right. So, this 2 less than or equal to 4 less than or equal to this condition is satisfied. So, we need only 2 flip flop, the number of flip flop is required is 2. We need to substitute n equal to 2, 3, 4 like that. So, when it is the condition is satisfied, the corresponding number we need to take, right. The number of states is 4. From this condition we identified n equal to 2, that is number of flip flop equal to 2. Here we are using the D flip flop. Now, we need to design the excitation table for the D flip flop. I will go to this table. So, this is the excitation table. It is a input x, so output y, that already we available in the table. This is the excitation table. This is a state table what we discussed. I drawn again in order to analyze the this excitation table is designed from the state table. So, that I draw the state table again, right. So, the state table what we discussed earlier same only. From the state table only we can design the D flip flop. So, that I drawn again, right. So, this is the input x equal to 0, x equal to 1, these are all the outputs. So, the input available, output available. Now, we need to see the present state, these two are present state, this is the next state, current state and next state. For that, what is the input to the DA? DA means first flip flop, DB means second flip flop. We are having 2 flip flop. So, the A is the first flip flop, D is the second flip flop. So, the excitation table aim is we need to find what is the value of D flip flop, what is the value of DA as well as DB, right. This only we need to decide what is the input to the first flop, what is the input to the second flip flop, right. For that we have input, output, current state, next state, right. What is that current state, next state? 0 0 to 0 0, right. So, this 0 0 to 0 0, for that input is 0, what is the output? That also 0, right. 0 0 to 0 0, 0 0 to 0 0, input 0, output also 0. Why I need to identify what is the input to the flip flop A as well as B. How to identify? For that, one more excitation table available for the D flip flop. This is the excitation table for the sequential circuit, right. What is the excitation table? Excitation table means from the current state and next state we can decide the what is the input required to the D flip flop. It is reverse of the truth table. Truth table, from input we can identify the output. Here from the output we are identifying the input. For example, 0 0, current state is 0, next state is 0 mean what is the input of the D flip flop. Current state 0, next state 1 means what is the input of D flip flop, right. In this D flip flop the current state is not taken into account. What is the value of next state? That is nothing but the input to the D flip flop. Otherwise, the input to the D flip flop will be reflected as a next state. This not bother about the current state. Whatever may be the current state, the next state purely depends upon the value of D input. D flip flop input will be reflected. See this, the D is 0 means the next state also 0, whatever may be the current state. D1 means next state is 1. D0 means next state 0. D1 means next state also 1, right. So, the next state and D input both are same. Otherwise, the next state purely depends upon the D input. Otherwise, D input will be reflected as a next state, not bother about the current state. So, based on this, now we need to identify the D value, right, the DA and DB. Okay. Now, see this 0 0 to 0 0, right. So, what we identified from this excitation table, the next state and D input both are equal, Q n plus 1 and D is equal. So, that the next state what is available, that is nothing but the input of the D flip flop, right. So, the next state 0 means D also, DA also 0, 1 means 1, 0 means 0. So, that is what we explained here, right. The Q n plus 1 0 means D 0, Q n plus 1 means D also 1, right. The next state and D input both are same. So, based on that we can write, right, Q A plus 1 is the next state of the first flip flop A. So, that will be reflected as a input of the D flip flop, both are same 0 0 1 1 0 0 1 1 everything. Similarly, second flip flop, the next state of the second flip flop, that is nothing but the input to the second flip flop, both are same 0 0 0 0 0 0 1 1 1 1. So, these two values are equal based on this explanation, right. Okay. Now, we will see the remaining terms 0 0 to 0 0, input is 0, output also 0, 0 0 to 0 0, input is 0, output also 0. What is the D input? That is nothing but next state. So, 0 0, 0 0 to then this will go this 0 1 to 1 0, 0 1 to 1 0, input is 0, output also 0, input is 0, output also 0. Then 1 0 to 0 0, 1 0 to 0 0, the input is 0, output is 1, input is 0, output is 1. What is the D value? D value is nothing but next state 0 0 means here also 0 0. Then 1 1 to 1 1, input is 0, output is 1, 1 1 to 1 1, input is 0, output is 1, right. Now, this condition over. Now, go to the next column 0 0 to 1 1, input is 1, output is 1, right. 0 0 to 1 1, input is 1, output also 1. Then 0 1 to 0 0, input is 1, output is 0, 0 1 to 0 0, input is 1, output is 0. 1 0 to 0 0, 1 0 to 1 0 to 1 1, 1 0 to 1 1. What is the input? Input is 1, output is 0, input is 1, output is 0, right. So, the first 4 case the input is 0, 0 0 to 0 0. For next 4 the output input is 1, right. The output depend upon this value. So, last one is 1 1 to 0 1, 1 1 to 0 1. What is the input? 1. What is the output? 0, right. So, from this table the excitation table is the for a design of flip flop the table is created, right. 0 0 to 0 0, 0 0 to 1 1, 0 0 to 1 0 like that, corresponding input and output. The value of D, DA and DB is nothing but the next state of the flip flop. The next state of the flip flop reflected as a D value, right, based on this explanation. The D0 means Qn also 0 irrespective of the current state, right. Now, we developed the excitation design of the D flip flop. Now, we need to identify the expression for DA, DB as well as output Y, right. Using the K map, we need to identify the minimal expression for DA, DB and Y. Now, we will go to the K map. So, the K map reduction, first we will go for the DA, the flip flop, first flip flop, the input for the first flip flop, right. This map is drawn, the input is X, QA, QB. X is the input, QA, QB is the current state. From that only we are going to identify the expression for DA, right. X, QA, QB. X having two options, X bar X, that is 0, 1. QA, QB having 4 options, 2 digit 4 option. 0, 0, 0, 1, 1, 1 or 1, 0. QA bar, QB bar. QA bar, QB. QA, QB, QA, QB bar. Right. So, based on the table, there are 4 ones available. These two ones are grouped together. These two ones are grouped together, left and right corner. While grouping these two ones, what we have here, X bar is there. Right. So, that X bar is written. Correspondingly, second and third column, QA and QA bar and QA got cancelled. Only we have QB, right. So, that X bar QB, that is the expression from by grouping these two ones. Then by grouping these two ones, the correspondingly what we have, X is available. We need to verify the first column and fourth column. See, this QA bar and QA got cancelled. We have QB bar on both the side. So, QB bar, X QB bar, right. So, we got the expression for DA equal to X bar QB plus X QB bar, right. Similarly, we can go for the DB. So, DB same thing, X QA QB, the 3 inputs, right. So, based on the table, previous table, there are 4 ones available. These two ones are grouped together and these two ones are grouped together. While grouping these two, what we have, same thing, X QB bar, in the previous case also same thing. While grouping these two, what happened, this first row and second row, X bar got cancelled. What is available in the third column, QB QA, right, QB QA. So, the DB is nothing but QB QA and X QB bar, that is very similar to the previous case. Then we will go to the Y, the output Y. The input is X QA QB, right. From the table, there are 3 ones available. These two are grouped together. This is available individually, alone, right. While grouping these two, correspondingly what we have, X bar. What is available in the third and fourth column? This QB bar got cancelled. Only QA is available, right. So, X bar QA, right. This one is correspondingly what we have, X here, QA bar QB bar, X QA bar QB bar, right. Now, we got the expression for output also. Now, we will go to the implementation of this expression using the logic gates. Now, we will see the design of this logic diagram. There are 2 flip flop, D flip flop. This DA, input is DA and this input DB. QA bar, output QB bar, right. So, now we need to design this QA. The expression for QA is nothing but X QB bar plus X bar QB, that is nothing but XOR gate. X QB XOR gate. XOR gate is, what is XOR gate? A B bar plus A bar B. Similarly, we have X QB bar, then X bar QB. So, that is given as a XOR gate, right. So, and then DB. DB is nothing but QA into QB. So, this is QA into QB. QA and QB is there, plus X into QB bar. This is X into QB bar. These two are multiplied and added together, that is given as a DB, right. DA and DB is given from the previous expression. Now, we need to design the Y. What is Y value? X bar QA, X bar QA. So, these two are multiplied. Other one is X QA bar QB bar. These two are multiplied and added together, that is the output. So, Y equal to X bar QA plus X QA bar QB bar, right, that is the output. So, this is the final design of the sequential circuit. So, in this video we discuss about the design of sequential circuit using D flip flop. The state diagram is given, from that state table, design of D flip flop, then reduction using K map, then the reduced expression is implemented with the logic diagram. Thank you for listening.